We're going to answer numerous questions about this particular word problem. It says a juggler throws the ball into the air and releases the ball 4.5 feet above the ground with initial vertical velocity of 18 feet per second. Using the model provided, graph the equation to the right. We're going to label the vertex, the y-intercept. 0 is also known as the x-intercept. And I'd like us to also label both the x and y axis within the context of this problem. Then we're going to answer a bunch of questions and also come back to answer this last question. Okay, so 4.5 feet above the ground, she tosses the ball. I can see that the y-axis is going up by units of 1. So 1, 2, 3, 4, 4.5. 0, 4.5. Okay, got that done. I also have commented I want you to label the axis. This is in terms of time. The ball is in the air, and the units would be seconds. On the side is the height of the ball above ground, and it's in terms of feet. Okay, we're going to grab the graphing calculator. If you have not done so, please clear out the two equations and let's type in what we see. This is not a subtraction, this is negative. Negative 16x squared plus 18x plus 4.5, and graph it. By a raise of hands, how many other people also have the same graph? Do you guys agree I have like a lot of extra room up here and on the sides? Do you guys agree with that? Let's come up here to Windows. Let's try -5 to +5. And maybe I only need to go up to, let's go -5 to 20. Let's see if that's a better range. Okay, I don't even need to go up that high. Let's move it down to, I don't know, 15. All right, good. Now I can see that a little bit better. Remember, this is the pathway of a ball when a juggler tosses the ball in the air. So it releases from her hand 4.5 feet above the ground. One of the things we were asked to do is to identify the vertex on the graph. The vertex can be seen here. It is a maximum. Please touch on your calculator second trace and go to maximum. Second trace, maximum. Left of the highest point entered, like you'd be doing the same with me. Right of the highest point enter, and back to the highest point. As a teacher, it is really defeating when I see a student that can get this answer and then they answer it wrong because they don't read the question. If I removed this calculator, it would say round to the nearest hundredth. Doesn't seem like a hard task, but a lot of students get it wrong. So let's review rounding. This is the 10th place. This is the 100th. This is 10th. This is 100th. How do you round to the 100th? That means that you go 2 places past the decimal, and you decide whether to keep this number or to round up based on the next number. Since 2 is not a number that's 5 or above, this will be 0.56, comma, 9.56. Okay, I want to get that. So I'm going to come up here. Please write that down. 0.56 and 9.56. So where is approximately 5? Well, here's 0 and here's 1. And how many points do we have? 1, 2, 3, 4, 5. Okay. Well, excuse me. A unit 1 has 5 little dash marks. That means every dash mark is 0.2. So 0.2, 0.4, 0.6. 0.5 is right in between. There's 9, 10, 9.5 is right about here. That is the vertex. I've graphed it and I've labeled it. Just graphing the point without an actual label here of where that point is located will not do. Word for 0 is x-intercept. Let's find the 0. Come back to our graph. I want to know, what is this point? Second trace 0. Left bound is above, right bound is below, and back to guess. Okay, let's round this again. So 1.3, okay, does it stay 3 or does it bump up? 1.340. Okay, so here's 1, 1.2, 1.4, 1.6. 1.3 is approximately here, and then I need to label it. 1.34, comma 0. take a blank piece of paper. We're going to go through several questions that help analyze this graph. Here's number 1. Please write a complete sentence. Please write a complete sentence. Feel free to use the graph that answers my question. Please write a complete sentence. You do not need to write the question down. How long did it take for the ball to meet its maximum height? How long did it take for the ball to meet its maximum height? Well, I can see here's the maximum height. Which one represents how long? How long is time? Time is the x-axis. It's the x value. So I'm not going to take time to write a complete sentence just for purposes of time to get through all these. Approximately 0.56. This would still be wrong because I need to put a label on it. 0.056 seconds. Number 2. How high above the ground was the ball when it was released from the juggler's hand? How high above the ground was the ball when it was released from the juggler's hand? That would be your y-intercept. The answer is 4.5. Remember, 4.5 above ground. We're talking about distance in terms of feet for this problem. Number 3. How high did the ball travel in the air? How high did the ball travel in the air? How high is referring to the maximum height. The maximum value is approximately 9.56 feet above the ground. Number 4. Assuming the juggler tosses the ball in the air and never catches it, how many seconds does it take before the ball hits the ground? Assuming the juggler tosses the ball in the air and never catches it, how many seconds does it take before the ball hits the ground? This is the height when the ball is 0 feet above the ground. How many seconds did it take? Approximately 1.34 seconds. The next question says this. As the ball travels, I want to know if this juggler tosses the ball with her left hand into the air and then reaches out with her hand as it is descending and catches it 5.5 feet above the ground. So please picture this. She tosses the ball with her left hand, she reaches out, she catches it with her right hand 5.5 feet above the ground. Well, first do me a favor, find 5.5 above the ground. So here's 5. And I want you to draw a line going straight across. This is the line y equals 5.5. Why is it y equals? Because it cuts through the y-axis. By the way, how many times is the ball 5.5 feet above the ground? Once or twice? Twice. Once when it's going up, it's ascending, and the second one it's descending, which means going down. So it says she catches the ball with her right hand when she's 5.5 feet when it's 5.5 feet above the ground and it's descending. I want to know how long does it take for her to catch the ball? 5.5 feet above ground when it's descending. Grab your graphing calculator, go to y equals, and we're going to go to y sub 2 and type in 5.5 and graph it. I want to know this point. So second, trace, intersect, use the arrows, there we go, first, second, and over the top. Okay, rounding to the nearest, this is the key, rounding to the nearest hundredth, this would be 1.07 rounded and 5.5. So if asked how long does it take, it would take approximately 1.07 seconds for her to catch the ball with her right hand as it descends and is 5.5 feet above the ground. The next one's on you. Are you ready? Please listen. I'm going to switch this up a little bit. I want to know how many seconds does it take? How many seconds does it take before the ball is 8 feet above the ground as it is ascending? How many seconds does it take for the ball to reach 8 feet above the ground as it is ascending. So here's 8 feet. I want to know this right here. 8 feet above the ground as it's ascending. How long does it take? Leo, what would you do to find this out? Leonel, what would you do to find that?
Just instead of putting 5.5,
Yeah, instead of putting 5.5, put 8. No, there's going to be 2 times when it's 8, when it's going up and when it's coming down. I want to know ascending, going up. So intersect. Now the key is round it to the nearest. Be very careful here. Round it to the nearest. Round it to the nearest hundredth. What would the answer be? 0.25 seconds. So it's like a quarter of a second it would take for the ball to reach 8 feet above the ground. Okay, next one here is we're going to do rate of change. Please write down this interval. Let me write it down neater, excuse me. I want to know the rate of change over the interval from 0 to 0.25. What is the rate of change over the interval from 0 to 0.25? Now, I want you to make sense of that because otherwise that's just hard to do. That means this is only in terms of x values, only in terms of x values of intervals. So from 0 to a quarter. So here's 0, here's 0.2, I want 0.25. So I want to know from here to here, what is the rate of change? Would you say it's going up or down? So is it a positive or negative number?
Positive.
Okay, that's a prediction. So in order to find out rate of change, which is like slope, again, note these are both x values. So please do 0 and do 0.25. Grab your graphing calculator. Go second. Once again, second trace value. Second trace value. Type in 0 for the x. The corresponding value is 4.5. Same thing, second trace value. Type in 0.25 and 8. Now to find out this rate of change over this interval, it is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 8 subtract 4.5 over 0.25 subtract 0. Make sure to use parentheses here when you're typing it in. We predicted a positive slope, and the answer is 14. If I was going to make a prediction, I would say that literally only a quarter of the students, 25% of the students, ever get this next question correct. Here's the question. Interpret the rate of change over this interval. Interpret the rate of change over this interval. I want you to think of your answer. Within this problem, what does this rate of change mean over this interval? Here's the answer. It means that the ball, by the way, I made a mistake. I had to write here, this is 14 is correct, but this is feet per second. It means that the ball increases 14 feet every second over the first 0.25 seconds. It means the ball increases, it goes up 14 feet per second over the interval from 0 to 2.25. A quarterback throws a pass down the field. He releases the ball 5.75 feet above the field, so above the ground, with initial vertical velocity of 25 feet per second. The ball models the pathway of the equation provided. Label the vertex, y-intercept, x-intercepts, and we also want to label both the x and y axes. So this is in terms of time, and it's in terms of seconds. This is in terms of feet. Oh, this is in terms of height, and it's feet above ground, or feet above the field, height above the field. All right, so the ball is released 5.75 feet above the field. Here's 5, here's 6, so I'm going to estimate that, but I do want to label it 0 and 5.75. Now to figure out the vertex and the x-intercept, known as the zeros, I'm going to use a graphing calculator. Go up to y equals and type in what we have for an equation that models this pathway. Sometimes students make a mistake by putting a subtraction sign here. This is a negative. I'm able to see the entire graph. I'm going to take out that second equation, and now I'm going to figure out what is that maximum. Second trace maximum. So left of the highest point, right of the highest point, and back to the highest point. All right, so the maximum, I'm going to write it up here, is rounded to the nearest hundredth, 0.66 and 12.64. Okay, let's graph that. So 0.2, 0.4, 0.6. Okay, so 0.6, 12, there's 9, 10, 11, 12, a little over 12 and a half, a little past 0.6. And now I want to go with what is the zero or the x-intercept, second trace 0. Left bound, right bound, back to center, 1.55 rounded to the nearest hundredth. So 1.2, 1.4, 1.6. Here are the questions you need to be able to answer. One question would be, how long does it take for the football to reach its maximum height? Well, this is the maximum height. How long does it take? Time is an x value. It takes approximately 0.66 seconds. Another question would be, what was the maximum height of the football above the ground? Approximately 12.64 feet above the ground. If nobody catches the pass, how many seconds will it be before the ball hits the ground? Answer is 1.55. All right, so Jacob passes the ball, and Anthony goes out for the pass here, and he jumps up in the air. Okay, so Anthony jumps into the air, and we're going to assume that he catches the ball 7 feet above the ground. He has a pretty good vertical. He catches the ball 7 feet above the ground as the ball is descending. Descending means coming down. So please go to 7 and draw a line going straight across. Notice the ball crosses 7 twice as it's going up and again as it's coming down. Well, we want to know, how long does it take for Anthony to catch the ball if he catches the ball 7 feet above the ground as it's descending? Please find that answer. Round your answer to the nearest hundredth. Second trace intersect. Using a little arrow here. First curve, moving it off, second curve, and back to the intersection point. And the answer would be, it takes Anthony approximately how many seconds? That's exactly, isn't it? It takes 1.25 seconds from the time that it's released from Jacob's hand to the time Anthony catches it, if it is caught 7 feet above the ground while the next one is going to be rate of change. So you can write it in here, rate of change. I want to know, what is the rate of change over the interval from 0.7, again, from 0.7 to 1.25. What is the rate of change over this interval? I'm going to provide you with 1 minute to do it. I'm going to work at the same time. Go ahead. What is the rate of change over this interval? I'm going to make a prediction before I hit enter. I know that at that point, 0.7 is right here. 0.7 is right here. 2, 4, 6, 7 is right here. From here to the point he catches, I know it's going down. So the slope or rate of change should be down over this interval. If I round it to the nearest hundredth, which it just goes to the nearest tenth, so I'm okay. I have negative 10.2. Hands raised if you get negative 10.2. What does that mean within the context of this problem? You have to be very specific. It means the ball is declining or going down 10.2 feet per second over the interval from 0.7 seconds to 1.25 seconds.